Hello, in this video, I want to show you how to approximate the constant E, 2.71828, blah, 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 how to approximate it as a limit, namely using this formula here, that this constant E equals the limit as n approaches infinity of 1 plus 1 over n, all raised to the n power. There are other ways to define E. In this section of James Stewart's calculus textbook, 6th edition, he suggests, for example, that E is that number such that the natural logarithm of E equals 1, which doesn't seem very helpful, but it is. But that's a different video. In this one, we want to show that this works. So let the games begin. Let's go ahead and say that f of x, this function, is the natural logarithm of x. Okay, I'm going to start there. Now, for reasons that will become clear, let's go ahead and take the derivative of this at 1. And remember, a long time ago, a faraway place, we learned that the derivative is the limit as x approaches, the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So instead of delta x here, we're just using x. And then we're going to go ahead and substitute in 1 for x in that formula. And so, by the way, f prime of x, we know that the derivative of the natural log of x is 1 over x. And so at 1 over 1 is 1. So this is 1. So 1 equals the limit as x approaches 0 of the function at 1 plus x minus the function at 1 all over x. Okay, well, what is the function? Well, the function is the natural log of x. So let's go ahead and plug in natural log of x. So limit as x approaches 0 of the natural log of 1 plus x minus the natural log of 1 all over x. Well, the natural log of 1 is 0. So that disappears. Whop, whop, and we're left with this. Also, the rules are we can go ahead and we can go ahead and pull that 1 over x out. That's the x here. And we're left with the limit as x approaches 0 of 1 over x times the natural log of 1 plus x. All right. We also know from the rules of logs that we can take this out of the front and make it a power. So 1, remember we said that f prime of 1 is 1, equals the limit as x approaches 0 of the natural log of 1 plus x raised to the 1 over x power. Okay, this is what we just had at the previous page. Let's keep going. Well, we know that E is e to the 1, and since this equals 1, then we can say that E is e to the limit as x approaches 0 of the natural log of 1 plus x to the 1 over x power, right? Why would you do that? Well, keep listening. So we can pull the limit out and say the limit as x approaches 0 of e to the natural logarithm of 1 plus x raised to the 1 over x power, okay? Well, these are cancellation equations, right? So the e and the natural log disappear, and we're left with the limit as x approaches 0 of 1 plus x to the 1 over x. Okay, we could stop there, but if we define n as 1 over x, then we get what we're looking for. The limit, so if x is 1 over x, then if n is 1 over x, then as n approaches infinity, then x approaches 0. So we can substitute in the limit as n approaches infinity. We've said that x is if n is 1 over x, then x is 1 over n. So that's where that came from. And then 1 over x is n. And voila, we have shown that the constant E is the limit as n approaches infinity of 1 plus 1 over n, all raised to the n power. Quoterat demonstrandum.